Hey, it's Dr. N. We're back again, and today we'll be talking about the unique wellness core system, the thyroid. This is one of the cornerstones of hormonal balance, and it's probably a good time for me to remind you that all functions in your body are controlled by communication between your brain, your hormones, and your immune system, what medical science calls the neuroendocrine immune supersystem. Now, the hormonal system is really quite complex, and it includes things like insulin and blood sugar regulation, or cortisol and adrenal and stress responses. It also includes all of your reproductive hormones, but one of the cornerstones is the thyroid. And we'll explain why the thyroid is so critical and important. All hormones are important, but the thyroid system and thyroid hormone function plays a particularly important role because it has connections to every cell in your body and every other system. Today, we're just going to be going through an overview of the thyroid system. This is actually pretty critical because most people think of the thyroid just as the gland or the hormone, but the thyroid gland and thyroid hormones are part of a much larger system that actually begins up in the brain and ends down inside every single cell that you have. And we're going to roughly divide all kinds of thyroid dysfunctions into three different types or categories. Then we're going to talk briefly about thyroid medications, and then we're going to do an introduction to autoimmunity. Now, if you don't know this already, we'll come to it in just a little bit, but it's critical to understand that 90% of all true thyroid dysfunctions are due to autoimmune mechanisms. And what that means is that the immune system is attacking the thyroid gland and affecting or destroying some part of its functionality. Now, there are circumstances where your thyroid might be not working, not because you have autoimmunity, but because you have other physiological imbalances that then have an impact on how the thyroid is working. In other words, the thyroid gland and system is actually fine. It's capable of doing its proper job, but you have something else that's actually affecting it, and that other thing is really the true problem. Nevertheless, statistically, 90% of all true thyroid conditions where the thyroid system itself is being affected directly, that is due to autoimmunity. We're going to hold that idea towards the end of this discussion and then come back and revisit that. So let's talk about the thyroid system. And what I mentioned just a moment ago is that the thyroid is a system. It's not just about this gland. And you see a picture here of the thyroid gland, which is, of course, in the front of your neck. And you've probably heard before the thyroid gland is a butterfly-shaped gland located in the front of your neck. And you may have actually seen this picture or something else. But that really doesn't tell us what the thyroid does. The thyroid, of course, produces thyroid hormones. And thyroid function supports everything in your body. In fact, I'll show you a graphic in a moment that shows that every single cell in your body has receptors for thyroid hormone function inside your cell located on your DNA. And so whether we're talking about the ability of your cells to make energy, the ability of your cells to burn fat for fuel, the ability of the neurons in your brain to have good balanced function and good brain chemistry and to be healthy over long periods of time and resist things like neurodegeneration, gut function, enzyme secretion, the maintenance of the mucosal system or whether or not you have leaky gut, liver detoxification, gallbladder function, all of these different systems are predicated in part and significantly influenced by your thyroid, which is why when someone has a thyroid disorder, they have symptoms all across the book because everything depends on thyroid functionality for its integrity and for health and wellness. And it's about much more than what you see on the screen here, but this kind of covers probably the most common symptoms that we see with our thyroid clients. Now let's back up a little bit and just talk about basic ideas related to hormones. And let's start by defining that. A hormone is a signaling molecule, and what that means, it's all talking about communication. A signaling molecule is something that tells a system or a gland or a cell to do something else. And in this particular case with the thyroid, the term that is used is called proteomics, and that just means the production of proteins, and that's proteins to help maintain cell structure and integrity, to renew and refresh tissues, or it might be the protein structures of different enzymes or other chemicals, like, for example, immune-based chemicals. These all have protein elements and protein structures. So a hormone is a communication tool. It's a signaling molecule, and specifically it's produced by a gland like the thyroid gland or like your pituitary gland or like your ovaries or your testes. And these glands release the hormones that are then distributed throughout the circulatory system. So they get dumped into the bloodstream where they get distributed around the entire body, and they have their impact in a place other than where they were released. So thyroid hormones get released from the thyroid gland, but they have to circulate all the way down to the tissues, for example, in your big toe and your ankle. Now, the action on the distant targets, as we mentioned earlier, is all about actually producing protein. But ultimately, what thyroid hormones do is that they regulate metabolism and cell behavior. So if we're talking about a muscle cell, good thyroid hormone activity in a muscle allows the muscle to be active, to make energy, to contract, to stay healthy. If we're looking at the impact on a neuron in the brain, it allows the neurons to make energy and to renew itself and to transmit signals from point A to point B. But ultimately, the ability of a hormone to do its job is based on its ability to find and to bind to its receptor. And hormones work on what we call a lock and key mechanism. So just imagine putting a key in the ignition of your car or sticking it in the lock of the front door at your house or your apartment. When you stick that key in and turn it, something happens. And so for thyroid hormones to work, they have to bind to thyroid hormone receptors. And then when the binding happens, assuming everything else is working well, then stuff happens on the other end. With a car, it's turning on the engine. With the lock to your front door, it's opening the door so you can go into the house. But with the thyroid system, the resulting action is dependent on the tissue and on the cell itself, right? But ultimately, it's about binding to and turning on the elements of cellular function and cellular behavior. Now here's a nice graphic, and you can find this, I believe I pulled this down from Wikipedia, kind of encapsulates this idea that we're dealing with a system. Let me give you some orientation here. This is your pituitary gland, or a representation of that. Of course, this is up in the brain. This doesn't make any distinctions about are we in the brain or somewhere else. But the pituitary gland, as well as your hypothalamus, live up in your brain, and they produce something called TSH. We're going to go over this again in just a little bit in a different fashion. This TSH then stimulates your thyroid gland. Here's your butterfly-shaped gland in the front of your neck. And then it produces thyroid hormones and get released into circulation. And then these hormones get taken up by cells, so they come out of the circulatory system into a cell where the hormones then go into what's called the nucleus. That's like the inner sanctum of the cell itself. And then they find their thyroid hormone receptors, they bind together, and they have an influence on your DNA. And again, as a result of that, we get what are called proteomic responses, which is the production of proteins. And these proteins have different effects depending on the type of protein and the type of cell. But this is where we start to divide three different types of thyroid problems, because we can divide this system and this process into three different rough categories. The first one is production. And so production actually happens in the thyroid gland itself. And we're going to come back and build some detail. I'm just giving you the big picture right now. So production happens in the thyroid gland, but of course it happens as a result of other things. Then we have a system of processing, and this really has to do with enzyme function and changing the nature of the hormones to prep them, to take them from their produced form and prepare them for their proteomic form, which is our third step here, which is the protein production. So there is actually some processing that happens of your thyroid hormones in preparation for them to bind to your DNA and then turn on protein production. So these are your three major issues here. We have errors in production, we can have errors in processing, we can have errors in proteomic responses or protein production inside the cell itself, or you can have more. You can have errors in each of these different areas, right? There's no rule book that says you shall only have production errors or you may only have processing errors. People with really bad thyroid issues can actually have all different kinds. They have multiple problems in multiple of these three different categories. So let's divide these things here now. I want to go back and just fill in some detail about the different hormones involved in the system. And I mentioned earlier The thyroid system begins in the brain. Well, if we understand that production happens in the gland, well, what tells the gland to make the hormones? And that's the result of things that are released by glands in the brain. And yes, you have endocrine or hormonal glands producing hormones in the brain. So the brain itself is, at least in part, a hormonal system, right? It's not just neurological, and it's very hard to draw these distinctions because brain, hormones, and immune system all work together. But up in the brain, we have two primary hormones that affect the thyroid system. And the first one is coming from a structure called the hypothalamus. And this hormone is called TRH, or thyrotropin releasing hormone. And what this does is it actually tells the pituitary gland, which is the next step in the process, to make another hormone called TSH. That stands for thyroid stimulating hormone. And this TSH is something that your doctor's been measuring, assuming that you've had labs with your medical doctors. But TSH is kind of the cornerstone of evaluating thyroid functionality because it is the hormonal signal that tells the gland to make more or less hormone. And it's kind of like a self-regulating system that if you're not making enough thyroid hormones, your brain kicks up the production of TSH to tell the gland, the thyroid gland itself, to make more hormones. If you have plenty of hormones floating around, then the signal coming out of the brain doesn't have to be as strong, and so your TSH goes down. And there's this inverse relationship between T4 and TSH, where if you have really high hormone levels, your TSH level will bottom out. But if you don't have enough thyroid hormones, your TSH levels go way up, which is why your TSH is a diagnostic indicator of actually having a low thyroid or a hypothyroid condition. But back to this big idea that the brain is where the thyroid system starts. That's true. It starts with TRH, it starts with TSH, but eventually the TSH escapes the brain environment because it is a hormone that goes into circulation like all other hormones, and it floats around, eventually hits the thyroid gland, binds to its own TSH receptor, and the result of that is the activation of thyroid hormone production inside the gland itself. Now, there are two kinds of thyroid hormones, and they are known as T4 and T3. Now, the numbers are really not all that important, but what these hormones do are. So the T4 is predominantly what comes out of the thyroid gland. And you look at these numbers on the screen here. When you ask the question, well, of all the hormones, thyroid hormones that come out of the thyroid gland, how much is T4, how much is T3? The answer is almost everything that comes out of the thyroid gland is this guy called T4. And only a little bit is T3. And here's the problem. T3 is the biologically active form, right? Your cells and the activation of your DNA, of your proteomic responses, is based on the ability of your cells to use T3. So if most of what's coming out of the gland is T4, we have to have some way to convert the T4 into T3 because what comes out of the thyroid gland is not enough to activate all cells in every system of your body. Now, T3 is 4 times more powerful than T4. Now, we usually say that T4 is biologically inactive and T3 is biologically active. That's not entirely correct, but I would say that easily 80 to 90% of what your cells take up and use to drive your proteomic responses is your T3. So as a general rule, we say that T3 is biologically active and T4 is not. But the bottom line is this. When your thyroid gland is activated by TSH, it makes mostly T4 hormones, which it dumps into your bloodstream, but T4 is not significantly able or capable of binding to and turning on your DNA, so we have to convert that somewhere, somehow, into the T3 version. We'll come back to that in just a moment. Now, there are some terminology that we need to clean up here because when the T4 and T3 are measured, you can measure what's called total T3 or total T4, or you can measure what are called the free versions or free fractions of those. So we have a free T3 and a free T4, as well as a total T3 and a total T4. I want to make sure that you understand the distinctions between those. So the first distinction is to actually understand, well, what does it mean when I say total T4? You know, my doctor measured my total T4. Well, the total hormone level, which is what that refers to, is actually made up of the sum of your free hormones plus what's called your protein-bound hormones. So we have free hormones which are biologically active and they are not attached to anything. So we just have a T3 or a T4 molecule floating around by itself, not attached to anything. That's what's called your free fraction. And then we have the same T3 and T4 molecules that are actually attached to a binding protein. And there are different ones. For example, albumin is a binding protein for thyroid. There's another specialized protein called transthyretin, which doesn't exist in large amounts in the body, but it's part of the transport mechanism. And then there's another one called thyroid binding protein or thyroid binding globulin, which is abbreviated TBG for short. But nevertheless, when you look at all of the hormones that are circulating in your body, you can pick out some free hormones and you can pick out some protein-bound hormones. And if you add your free plus your protein-bound, that represents your total hormone level. But here's the issue. The free fractions are the biologically active ones. In essence, what happens when you attach a binding or a transport protein to a free hormone, it turns it off. It makes it biologically inert and incapable of finding and binding to the hormone receptors. So in order for the free fraction hormones to get into the cell to bind to the receptor site, they have to be unattached. They have to be free fraction and not protein bound. But if we look at the distribution of all the total hormones that are available, what percentage is in the free form and what percentage is bound to a transport protein, the numbers are actually quite staggering. For example, with free T3, it represents only 0.3% of your total hormones. And for free T4, that represents 0.03% of total T4. And what that means or translates to is that when you look at your total hormone pool, the amount of hormones for T3 or T4, they're almost entirely attached to binding proteins or transport proteins. And in the case of free T4, 99.97% of all T4 molecules in circulation are protein bound and they're therefore inactive. And we can say the same thing or similar thing for free T3. Of all the T3 hormones that could potentially enter into your cells and bind to your DNA, only 99.7% of those are biologically inactive because they're bound to a transport mechanism or a transport protein. So we have this big picture, and let me go back and just kind of reiterate this one more time. The thyroid system starts in the brain. Your hypothalamus makes TRH. That stimulates the pituitary to make TSH. TSH then causes the production of thyroid hormones, mostly T4 coming out of the thyroid gland, and most of that is going to be protein bound. Well, we need to have some way to convert that to T3 and for the binding proteins to be separated from the free fraction hormones to actually get into your DNA, because ultimately at the end of the day, it's only the free fraction or free version of T3 that has the potential to stimulate your cells. Right? Now that's a profound statement. Most of what's floating around is protein bound. Most of what's floating around is T4 and not T3. So cellular activation is predicated on taking what comes out of the thyroid gland and prepping it or processing it so that it is biologically available to turn on and activate your cells. So here's another way to look at it. We can divide it between your active thyroid hormones and your inactive thyroid hormones. The only biologically active hormone that we really need to be concerned about is your free T3. It's really the only version that has any significant biological activity, and most of the free T3 in your system is not what comes out of the thyroid gland, but it's a result of converting T4 into T3 as part of that processing aspect of thyroid functionality. The inactive thyroid hormones then are your T4 hormones, and that would include the free T4 as well as the protein bound or the total T4. And it also includes a couple of other characters like reverse T3, which I'll explain a little bit more detail about that in just a moment. Reverse T3 is also biologically active. Your total T3, because it is predominantly protein bound, is also predominantly inactive. And then we have a couple of other T3 versions called T3 sulfate and T3 acetic acid, and these are byproducts of the processing system. So let me put it to you this way. If you're looking at your labs and you're asking the question, well, what's my production status? What's coming out of my thyroid gland The number that you're going to want to look at is your total T4 number, your total T4 number. That will tell you what's coming out of the gland or the result of thyroid glandular activation. If your concern is to estimate or evaluate how much hormones you have available to you to bind to your cells to actually create function, which is a different part, it's the same process, but it's a different part of the equation, so to speak. Then if you're concerned about cellular function and activation, you want to look at your free T3 level. So, if your doctors that you've been working with have just been relying on things like TSH or TSH plus T4, they're only looking at certain parts of the system. They're not able to make an estimation or evaluation of the entire system just simply by looking at little bits and pieces of a very complex and a very integrated whole. So to say it one more time, if I want to know what's coming out of your thyroid gland, I'm going to look at your total T4 level. If I want to know what's available to turn on your DNA at the cellular level to create function, I'm going to look at your free T3 level. That's going to tell me what's coming out, what's available. So let's put this together kind of in a graphical sense. Well, again, we start up in the brain in this structure called the hypothalamus, and that makes TRH or thyrotropin releasing hormone. That stimulates the pituitary gland, and then the pituitary gland uses another hormone called TSH to turn on the thyroid production facility, right? Inside your thyroid gland, you have specialized cells called follicular cells that actually make your thyroid hormones. Now, I'm not going to go into the details of how all that happens. We'll talk about that in another installment of the thyroid series when we get a chance to talk about autoimmunity and the impact that it has on thyroid gland function. But once your thyroid gland is turned on, so to speak, you make thyroid hormones, you dump those into your bloodstream. They're attached to binding proteins because that's what allows them to circulate without being taken up by your cells. And these protein-bound T4 and T3 circulate around through the body, and then they start interacting with different cells and different tissues. Now, again, I've noted here, and you'll see the T4 is large and the T3 is small, and that's just to reflect the fact that most of what comes out of the thyroid gland is actually T4 and not T3. But combining this with the understanding that it's really your free T3 that gets into your cells, how do we convert T4 into T3? Well, most of that action happens in the liver. Now, honestly, T4 to T3 conversion happens in all cells to different degrees, but the liver is particularly active in this respect. And there are a series of enzymes. These are called 5' deiodinase or deiodinase enzymes, just to fill in a detail. And these enzymes are responsible for converting T4 into some version of T3. And I say some version because there are different enzymes and different capacities to convert into whether we're talking about an active version of T3 or inactive. So let's take a look at the graphic here. These enzymes, these deiodinase enzymes, predominantly in the liver, normally, under normal circumstance, convert about 60% of the T4 coming into the liver, get converted into biologically active T3, which is what we're looking for, right? The biologically active T3, then the binding protein falls off, that T3 enters into the cell, and we get activation of function and the maintenance and promotion of health, right? That's your biologically active T3. But going back to the middle here, with these enzymes, there are some enzymes that don't convert into the active T3. They convert about 20% of the T4 coming into the liver into inactive T3, and this would be your T3 sulfate and T3 citric acid. Now, the interesting thing here is that inside the gut, there are certain enzymes called sulfatases. This is part of your mucosal system. So as long as you have a healthy gut, then you can actually take these inactive T3 levels. And I just realized that I have a typo here. Should say inactive T3 instead of active T3. But nevertheless, once your liver converts T4 into inactive T3, if you have a healthy gut, you can reclaim some of that. And that actually ends up coming back into the active T3 pool and then promotes global cellular activation and health. But there's another portion of the T4 that gets converted not into active T3 or not into recoverable inactive T3. It gets converted into what's called reverse T3, which is not just inactive, but it's also unrecoverable. And what that means is that, it doesn't matter if your gut is healthy, doesn't matter what else is going on with your health, you can never reclaim reverse T3 once it's converted. So reverse T3 is a biologically inactive variant of T3, and this is normal metabolism. In fact, the physiologists tell us that this is kind of like a pressure valve. This is a mechanism by which we prevent overstimulation of our cells, because we don't want our cells to be overstimulated. We don't want them to be understimulated either. But nevertheless, once you get conversion into reverse T3, then you can't get that back. Now here's the deal. The profile of the conversion right here under normal circumstances, it's 60% goes to active T3, and that's good. 20% goes to inactive T3, and that's okay if we have a healthy gut. And then the other 20% goes into reverse T3, and we can never get that back. The efficiency of that percentage or that profile is completely modifiable by your diet, by your lifestyle, by your stressors, whether or not you're inflamed, what's going on in your environment, and your nutritional status. And so what happens is when you have metabolic issues, whether it's a blood sugar problem or a chronic infection or a leaky gut or chronic stress that you can't adapt to or resolve, it changes the percentages of what goes into which pathway, so to speak. So you may see that somebody is chronically stressed and inflamed, and they make less active T3 and more reverse T3. And that's not necessarily a thyroid disease. That's a metabolic impact on the thyroid that causes a thyroid issue, but the primary problem is the stuff that's driving the thyroid dysfunction. It's not the thyroid itself, right? And these patterns can exist with or without autoimmune issues. So again, you can have primary thyroid issues, which are predominantly autoimmune in nature, or you can have secondary thyroid problems where something else is messing up a perfectly good thyroid system. And if you can resolve those other things, then you can get your thyroid function back. So one more time, starting up at the top left, the brain, hypothalamus talks to the pituitary talks to your thyroid. The thyroid makes thyroid hormones, mostly T4, connects them to a binding protein, puts them into the bloodstream. They float through the bloodstream, eventually passing through the liver, where there are enzymes that convert it into either active, inactive, or reverse T3 variants based on your diet, your lifestyle, your stress, your inflammation. In fact, there are some genetic influences here too as well. Right? Those enzymes can be subject to genetic variables that for some people can work very efficiently, or for some people don't work efficiently at all. Unfortunately, we know that happens, but we just don't have any testing to show it in a clinical setting, unfortunately. Now, let me talk a little bit more about the reverse T3. We already said that this was always inactive and you can't recover it. Another problem with reverse T3 is that it can find and bind to your thyroid hormone receptor. So it kind of acts like the normal T3, but it does not activate proteomic responses. Right? When I do these lectures and we go through thyroid physiology like this with our doctors, I talk about how reverse T3 is your deadbeat brother-in-law. Sits in your favorite chair, hogs the remote, eats your pizza, doesn't have a job, doesn't help around the house. It just kind of sits there and takes up space. And so when you have reverse T3, especially if you have higher levels than normal or higher levels in relationship to your active T3, then it just kind of sits in the thyroid receptor, but it doesn't turn anything on. And so you end up with a whole bunch of thyroid hormones floating around not being used because they can't sit in their favorite chair. They can't actually bind to the receptor sites. And that can dramatically reduce thyroid function. Some of the estimates in the science suggest that higher levels of reverse T3 can reduce active T3 function by about 30%. And that can be significant because that's every cell and every function that each of those cells serves, including things like protecting your brain and your bones and producing energy. So this is your thyroid system, right? It's not just about the gland and your TSH or T4. It's really actually quite a bit more complex than this. And I'm not going to go into the details because it gets very complicated very quickly, but there are other dimensions to this. And I will mention, for example, up here in the top left corner, up in the brain, the ability of your body to make TRH and TSH to tell the gland to make thyroid hormones is in part predicated on neurotransmitter function. It's based on serotonin and dopamine. So anything that affects serotonin and dopamine can affect thyroid function. And one of the biggest things is blood sugar issues. So now all of a sudden we throw in brain chemistry and neurotransmitters and blood sugar control, which means diet and genetics and exercise. And you realize that looking at a thyroid issue is not just as simple as measuring the TSH and saying thumbs up or thumbs down, right? It is quite a bit more complicated than that. Now, let's go back to this idea of 3 different types of thyroid problems, right? We've already defined production, which happens in the gland. We've defined processing, which is this enzymatic conversion. We've talked about proteomic, which is really protein production and promotion of function through that. So with errors of production, something goes wrong with making enough thyroid hormones. The site of the problem is actually within the thyroid gland itself. And this is where we get to kind of hit again that most of these are autoimmune issues. Now, aside from that, you may not have a production problem. You may not have thyroid autoimmunity, predominantly what we call Hashimoto's disease. Maybe you don't have a primary thyroid issue, but maybe you have a problem with either the level of your binding proteins, which changes how much free fraction stuff you have, or maybe you've got a problem with these enzymes in your liver that convert T4 to T3. And it doesn't necessarily just mean cleaning up your liver and doing a detox is going to fix everything. Sometimes that can produce magic, so to speak. But it does mean that we have to go back and re-examine all of the diet, lifestyle, and environmental factors that can potentially affect the processing problem. And then we have a whole other set of categories, which is your proteomic responses. And this is where your cells don't respond, your receptors don't work, you've got something blocking your receptor like your reverse T3. There are other things that will do that. For example, chronic inflammation, chronically high cortisol, certain nutrient deficiencies can do that. So to understand what's going on with your thyroid, we really need to have a full thyroid panel that lets us evaluate every single step in the process. And then we look at all of the data and we look for what we call patterns, because each of these different error problems or areas of errors will show up in the blood work with specific patterns, right? Numbers go up, numbers go down, and depending on where your problem is, it will present as one pattern versus another. And yes, you can have more than one problem at one time. And this is where blood work and looking at that in conjunction with your symptoms and other lab tests becomes very important for understanding how all this stuff fits together. So here's just overlaying these ideas of production, processing, and proteomic errors on different parts of that graphic. Now, how do you know where and what the problem is? Well, it's all about the proper lab testing, right? And here I have a list of the things that we typically look at to make sure that we understand the patterns, right? It's TSH, we have to look at the total and the free T4, total and free T3. We need to look at your reverse T3 levels. And if we want to evaluate whether or not you have autoimmunity, we have to look at one or two of several different antibody types that can be associated with it. And then again, recognizing the pattern that's associated with the location or type of problem that we're dealing with. Now let's move on and talk about thyroid medications. And you may or may not be on thyroid medications, but a lot of times questions come up like, do I need to be on thyroid meds? How do I know? If I do need meds, what's best? And, I hear bioidentical is great, although maybe some people say synthetic works well. How long do I need it for? Let's address each of these in turn. Knowing that you need thyroid medications is really a result of one thing, and that's whether or not you have a persistently elevated TSH. Now remember, we said earlier that your TSH goes up or down in the opposite direction of your T4 levels. So remember, T4 is what's coming out of your thyroid gland. So if you're making plenty of thyroid hormones and you've got plenty to go around to your cells, then there's no need for your brain to keep driving high amounts of production. So this is really kind of a homeostatic or a balancing act. If I have plenty of hormones, I taper back my production request. If I use up all my thyroid hormones or I can't make thyroid hormones and I don't have enough coming out of my thyroid gland, then the brain senses that and says, I need to kick up production. And so TSH levels will go up when your T4 levels are down. And so if you have a primary thyroid dysfunction that results in the inability to make enough thyroid hormones, your TSH will go up above the lab range and it will stay up. Now it may fluctuate, and depending on where you are in the progression, sometimes you may have better TSH output and thyroid function than others. That actually is a sign of autoimmune issues. But when your TSH is diagnostically above the lab range and it stays that way, that's when you know you absolutely need thyroid medications. Now, some people on thyroid medications are given that too quickly or without trying to differentiate whether or not they have a primary thyroid issue, mostly autoimmune disease, and they end up on thyroid medications not because they have a primary thyroid defect, but because they have these other metabolic issues that are affecting an otherwise normal thyroid system. And those are the people that may be on thyroid meds right now and can get off them if we can fix these other things. They really don't need the thyroid medication at all. But assuming all other things being equal, if you have a chronically high TSH, you need to be on thyroid meds, not only because that's a sign of chronic hypothyroidism, but because the TSH is going to chronically stimulate the thyroid gland to make more hormones, even though it doesn't. It's going to chronically stimulate the thyroid gland itself, and that can cause goiter. That can cause a permanent enlargement of thyroid gland, and that's where you see these pictures of people with really large necks. And these, quite honestly, we've seen studies and pictures that are published in the medical research where sometimes these goiters get so large they go down behind the sternum, behind the rib cage, and it can actually, if they grow large enough, can start affecting things like heart and lung and swallowing reflexes. Now, those are extreme examples, but I want you to know that having a chronically high TSH is nothing to mess around with. Now, every circumstance is different, and we always want to give our clients' bodies a chance to correct things with the right direction. And maybe it might look in the beginning that you need meds. Maybe you don't. Sometimes the only way to figure that out is to do the right things, to do what we know based on your lab tests, and then figure that out within a reasonable period of time, whether it's 6 weeks or 8 or 10, really depends on each individual person. But if despite everything you've done, your TSH is still high, you need thyroid medication. Now, the other thing that you know that you would need thyroid medication is that if you do have a primary thyroid disorder, and that's where something's wrong with the thyroid gland itself, that's mostly autoimmunity, and that will represent a permanent loss of thyroid production because autoimmunity destroys the cells or the ability to make thyroid hormones. Right? So we have some fairly clear-cut guidelines about whether or not thyroid medications are necessary, but for any one individual person, we give their body the right and the opportunity to prove that they don't need the thyroid medication, but it's predicated on trying to find and fix all the other things that could impair a normal thyroid from working the way it's designed to. And what about the second question? Well, what kind of thyroid medication is best? Well, we have two camps. We have the majority of the conventional medical system, which says synthetic is the only thing you can trust. And most docs are prescribing a synthetic form of T4, like levothyroxine or Synthroid. But then you have the other camp, which is mostly the more integrated or alternatively minded medical doctors and DOs and nurse practitioners who say, no, well, bioidentical is best because it's exactly what your body makes. Well, honestly, it's not about the medication. It's about you as an individual and what works best for you. Because here's what we see in clinical practice. We see some people not getting good results from synthetic hormones, switching to bioidentical hormones and getting better just by making that change. But we also see people going from synthetic to bioidentical just because they think it's a good idea, and they crash and burn and they go back to synthetic and they get better. We see people who start out on bioidentical and don't do well, and then go to synthetic and do better. So it's not about the medication. And yes, I would love to live in a world where it was as black and white that if it's synthetic, it's bad, and if it's bioidentical, it's good. But the truth is, we live in a world of a million shades of gray, and it's not about the medication. It's about you and your body and what your body is going to respond best to. Now, the good thing is that sometimes the lab patterns tell us which medication is necessary. So for example, and I hope you can follow me without me having a graphic here. Let's go back to the conversion issue, right? Processing. If I am inefficient at converting T4 into T3, and it's the T3 that goes into my cells to do the job, I want to get to work finding and fixing the things that are changing my conversion capacity. But in the meantime, if I can't convert T4 to T3, what's the point of giving me more T4? In a circumstance like that where we see an underconversion pattern, it is almost always, and I'll say almost always better to have someone on a bioidentical hormone, because part of that bioidentical makeup and formula is to include some T3 hormone, right? So sometimes the pattern can tell us definitively and without a doubt, you need a T4 plus T3 combination, which you're mostly going to get in the bioidentical world, right? Sometimes people work very well with synthetic T4 because their conversion process is very efficient. So you just dump T4 in and it converts automatically to the proper active form of T3, but not everybody is the same. And again, sometimes the pattern tells us what we want to know. I will tell you that sometimes trial and error is necessary. Right? There are some guidelines and some indications from lab patterns, but sometimes you just need to try it and see what happens. But you have to be cautious. A lot of the thyroid medications, particularly the synthetic versions, they contain like cornstarch. Some of them contain gluten, believe it or not. Some of them contain immune stimulants like acai, or some people are sensitive to things like magnesium stearate, that kind of stuff. So there are things in thyroid medications that people with immune sensitivities can react to, and you might take a synthetic hormone and get worse, not because that hormone was bad for you, but because there was something in the pill that your immune system responded to, right? And again, oh man, I wish it was black and white. It's just that's not the life we live as clinicians, and that's not the life that you live as a person trying to get well. So sometimes we have to make a choice, observe the response, and then make a better choice after that. Now, what about this final question? How long do I need meds for? Well, it depends. Do you have a primary thyroid disorder that has resulted in permanent reduction of thyroid hormone production capacity? Then you're going to need meds forever. But if you have a secondary problem where something else is messing up an otherwise normal thyroid system, fix that other stuff, and you're not going to need meds anymore because you haven't lost permanent production capacity. And this is where it's really important to understand at least the fundamentals of autoimmunity, and we're going to have another probably 2 sessions on this in this series. If you have an autoimmune issue against your thyroid that's causing a hypothyroid condition, most of those are, again, they're autoimmune. They end up in destroying your ability to make hormones, and there is permanency to that. So how long do you need meds for? It depends. Primary or secondary, do you have autoimmunity or not? Or let me throw one more thing in there. Are you not producing hormones because of a genetic deficiency? Let's say that you are genetically a poor T4 to T3 converter. And no matter what we do with diet and lifestyle and everything else, we can't improve your ability to take T4 coming out of your gland and convert it into T3 for your cells to use. In that case, you're probably going to need a T3 hormone, whether it's a bioidentical T4, T3 combination, or you can get a synthetic T3 by itself, for example, in something like Cytomel, for an example. Now, the real understanding for thyroid issues and medications, all these things, really begins with knowing the fundamentals about autoimmunity. Now, so here's my 20-second introduction, because this topic is too detailed for me to tag on to the end of this introductory thyroid system talk. 90% of all thyroid conditions are autoimmune. That includes low thyroid and high thyroid. So Hashimoto's on the low side, Graves' disease on the high thyroid side. So Graves' disease is a autoimmune hyperthyroid condition. Statistically, the vast majority of thyroid conditions are Hashimoto's, and so our talks and our educational processes geared around those things. But when we deal with autoimmunity, there is a degree of permanency to that. And I will be very frank with you. Nobody, I don't care who they are, what discipline they're from, what their background is, what shaman or Ayurvedic guru they studied with, nobody can cure autoimmune disease, at least not yet. Maybe someday we will. It is not about curing autoimmunity. It's about learning to control the mechanisms and the triggers that drive your immune system to be more aggressive against your thyroid gland, and as a result, cause more progressive forms of Hashimoto's or hypothyroidism. It's about immune control and balance, and the primary strategy is finding and fixing, eliminating, and managing the common triggers for immune activation and inflammation. Now, I'm going to leave that discussion for another time, but that's really kind of the basic introduction. The next time we meet on this series, and you'll get the next lesson in not too long from this one, we're going to be building a little more understanding of autoimmunity. And then we're going to talk about the best-selling book on thyroid disorders and Hashimoto's in particular, which has been published by a friend and a colleague of mine, in which I have several case studies published. We'll talk about that, and it's something that if you don't already have it, we need to get it into your hands, because my friend Dr. Karazian spends a lot of time really developing detail and showing you things that we're going to teach you as we go through this process. All right. So thanks for listening. As always, you can go back and you can re-listen to this, but we'll talk to you again soon.